Alright, in this video we're taking a look at how to apply significant digits to the answers to calculations. So you're doing some kind of chemistry or math calculation and you want to know, how should I round off the answer that I see on my calculator? Well, it depends on whether you're doing an addition, subtraction question or a multiplication, division question. If you're doing an addition subtraction question, then you want to focus on the number of decimal places in each of the numbers that you're adding or subtracting. The answer to the question has to have the same number of decimal places as the number in the calculation that had the fewest decimal places. On the other hand, if you're doing a multiplication division calculation, now you want to focus on the actual number of significant digits in the numbers being multiplied or divided. Here, the answer has to have the same number of significant digits as the number in the calculation that had the fewest. And of course, this could get more complicated. You might have a question where you're adding, subtracting, and multiplying, dividing all in one question. We won't go into that in this video, but it's not that much harder. There's also questions about what to do if you're adding, subtracting with scientific notation. Well, that is a little bit more complicated, and again, we won't go into that in this video. So we'll keep this as a simple introduction to basic arithmetic calculations, how to round off answers. So let's look at some examples. Here we're looking at 3 questions, and if you just quickly glance at them, you'll notice that these fall into the category of adding and subtracting. So the first 2 examples were subtracting numbers, and in the third example we're adding a bunch of numbers. Now what I've done for you is I've shown you in the video here what your calculator will display as an answer. So if you take 2.70 and you subtract 0.153, your calculator is going to say that the answer is 2.547. But how do we round off the answer? What do I write down as the actual answer to my chemistry question? Well, now I want to realize I'm adding or subtracting, in this case subtracting. So we're going to look at the number of decimal places in the 2 numbers being subtracted. So 2.70, there's 2 decimal places, 0.70. In 0.153, there's 3 decimal places, 0.153. So my answer has to have the same number of decimal places as the number in the calculation that had the fewest. So since there were 2 decimal places and 3 decimal places, I'm going to round off this answer to have only 2 decimal places. So 2 decimal places, it can't go past this decimal. So 2.547 will end up being rounded off as 2.55 is your final answer. Okay, now if you think you understand that, pause the video and see if you can round off the next 2 answers. So in part B, you're rounding off. Here you've got, again, a subtraction question. So when it's an addition or a subtraction question, we look at the number of decimal places in the numbers being in the calculation. So in this case, 2 decimals and 2 decimals. So our answer has to have 2 decimals, right? The problem here is that when I do this on a calculator, it says 9.3, which only has 1 decimal. So how do I get a second decimal? Well, the answer is just to throw in a 0. Okay, adding a 0 doesn't change the number, but it gives us 1 more decimal place. So 9.30 would be the correct answer. Now you might argue that that's the same thing, just as 9.3. Well, I get that from a math perspective, but you remember from a science perspective, 9.3 and 9.30 communicate 2 different things. 9.30 with the extra digit implies a greater level of accuracy or certainty in the number. So that extra 0 means you're more certain that it's 9.30 and not, for example, 9.25 or something like that. So the extra 0 changes the meaning of the number. But on a calculator, of course, 9.3 and 9.30, your calculator is going to do the same thing with those numbers. Now, part C is an addition question, so again, we're looking at decimal places. Now, the first number here, 16, it has no decimal places, and so that's actually going to rule how many decimal places we keep in the answers. because the second one had 2 decimals, the third number has 1 decimal, and the fourth number here has 3 decimals. But since the first number had no decimals, my answer ends up having no decimals. It has to have the same number of decimal places as the number in the calculation that had the fewest. So 16.352, I've got to round off so it has no decimals. So since the next digit is a 3, I'm going to just leave this as 16. If this had been 16.552, then I would call it 17. You'd have to round it up at that point. But here we're going to just keep it rounded off at 16. All right, here's 3 more examples, and a quick glance tells you that here we're actually not adding, subtracting, instead we're multiplying and dividing, and I've thrown in some scientific notation questions as well. So in part D, we've got 2.5 times 3.641, and your calculator would display 9.1025 as the answer. But what should I write down as my answer on a test? Well, now since I'm multiplying and division, we don't look at decimal places, we look at significant digits. So 2.5 has 2 significant digits. If you're rusty on counting significant digits, you want to go back and look at that other tutorial video on how to count significant digits. So 3.641 has 4 significant digits. The only question when it comes to counting significant digits is zeros, so those 2 numbers were easy. 2.5 and 3.641, so I've got 2 digits and 4 digits. My answer has to have only 2 digits. Okay, the smaller number of significant digits. So 9.1025, you're going to get rounded off to just 9.1. So it has 2 significant digits. Part E, you're taking what looks like a question from the first unit of grade 12 chemistry. 3.00 times 10 to the 8, of course, that's the speed of light. And you're dividing it, this could be, for example, a frequency that you're dividing by. And this answer would be the wavelength. Now, 3.00 times 10 to the 8 has 3 significant digits, 3.00. 522.5 has 4 significant digits. And so my answer, excuse me, has to have only 3 significant digits. Leading zeros do not count as significant digits. So with 3 significant digits, the answer is going to be 574. So 0.574. Okay. Pause the video and see if you can do the last one on your own. So 6.626 times 10 to the minus 34 has 4 significant digits, multiplied by 3 significant digits, 3.00 times 10 to the 8, and then divided by 2 significant digits, 5.1 times 10 to the minus 7. Remember that the 10 to the minus 34, the 10 to the 8, 10 to the minus 7, those are not significant. So we've got 4 significant digits times 3 significant digits divided by 2 significant digits, multiplying and dividing only. My answer is going to have the smallest number of significant digits, which is just 2. So 3.897647 blah 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 times 10 to the minus 19, you're going to be rounded off to just 3.9 times 10 to the minus 19. Okay, so that number has 2 significant digits only. So those, a quick tutorial on rounding off answers for just addition, subtraction, multiplying, and division. Addition, subtraction, focus on the number of decimal places, and multiplying and dividing, focus on the number of significant digits when you're rounding off your answers.